Every beat of your heart is an explosion, not of fire, but of electricity. It's called an action potential, a precise surge of ions that tells the heart when to squeeze and when to rest. But if you gave a frog's electrical code to a human, our hearts would fail in seconds. Across the animal kingdom, evolution has rewritten the laws of biophysics to keep the spark alive. In amphibians, the heart is a master of patience. Their action potentials have an incredibly long plateau. Because frogs are cold-blooded, their ion channels move like molasses. But then, mammals turned up the heat. To support warm-blooded life, we needed speed. Mammalian action potentials evolved complex sodium Na+ and potassium K+ channels that reset almost instantly. We introduced a biological failsafe, the refractory period. It prevents the heart from contracting twice too quickly. In a hummingbird, this reset happens 1,200 times a minute. It is the most high-performance circuit in the known universe. Size creates a massive problem. In a blue whale, the electrical signal has to travel meters, not millimeters. To stay in sync, whales evolved Purkinje fibers, biological superconductors that move electricity at lightning speeds. Without this architecture, the whale's heart would wobble itself to death. From the pond to the abyss, the heart proves that the spark must go on. Subscribe to see how nature powers the impossible.